Welcome back to another CADCAM tutorial. This is another Siemens NX versus SolidWorks tutorial video, and you are going to model these same parts with Siemens NX. And then we model it with SolidWorks so that we can compare the 3D modeling workflow between these two CAD softwares. This is a drawing of the part. We have the top view. This is a section view, section AA, that cuts through the top view, showing these hidden features inside the parts. And this is the right view. And we have the isometric view as well. All dimensions are in millimeters. All unspecified fillets have a radius of 3. So the fillets on these edges here have a radius of 3. And then a chamfer on this edge. So this chamfer here is 3 millimeters and it's a symmetric chamfer. So this is very simple to do. Before we begin, if you're new to this channel and you want more tutorials like this in Siemens NX and SolidWorks, make sure to hit the subscribe button and turn on post notification so you don't miss any tutorial. And leave a like on this video if it helps you out. Now let's proceed. We are going to start with Siemens NX. So we are inside the Siemens NX window. Click on New and set the template to model because we are modeling a new part. As we can see, all dimensions are in millimeters. We set the unit to millimeters. Specify a name for the part and a folder to save it. Okay. And this will take us to the Siemens NX 3D modeling workspace. We can start. Looking at this part very well, it can be divided into two different components or two main components. The base cylinder and then the top cone. The cone and the cylinder are both round figures. So we are going to use the revolve feature to get the two figures. So first create a sketch on this YZ plane, which is the right plane. Okay. And then we sketch half of this profile and dimension. So with the profile tool, sketch half of the profile. And less dimension. So the outer diameter of the cylinder is 180 millimeters. And then the diameter of the base of the cone is 120 millimeters. So from this line to this line, since we sketched just half, it will be 180 divided by 2. And from the base of this cone to this center line, since we sketched half, that will be 120 divided by 2. And then the vertical distance here is 20, and the total vertical distance here is 100. And from this line to this line is 20, and from this line to the end line here is 100. Now the angle of inclination between this inclined line and the middle vertical line is 20 degrees. As we can see, sketch fully constrained. So finish sketch. Then we are going to revolve. So under the extrude, we have this revolve feature. Select curve. Make sure connected curves is selected, and then click on just one line. You can see that all the lines have been selected. Now the axis of revolution, just click on this vertical line of the sketch. And then the angle of revolution, the start angle 0, the end angle 360 for a full revolution. Okay. Next, we add these extensions on the cone. We are going to add just one, and then we pattern to get 1, 2, 3, 4, 5. We pattern to get 5 extensions in total. So we create the first one here. So again, revolve sketch section. We're going to use the same YZ plane. Okay. I want the display to be static wireframe, so we can have these edges only showing. So now we are going to create this profile and dimension. So we have an inclined line here, and then close out the shape. Now let's dimension. So the distance between this point and this line is 19, and the angle of inclination between this line and the horizontal line here is 20 degrees. So from this line, and just right click, select from list. We want this line of sketch here. So this angle is 20 degrees. Okay. Now I'll click on this and just pull it here. Okay, so this is okay. And the distance between this point and this line, this inclined distance is 19 millimeters. The full distance here is 48, and this is 6. From this line to this line is 48. And this length here, the inclined length here, is 6. Okay, so we want to make sure that this line and this line are parallel. So just zoom in, click on this line, and then click on this line. Make them parallel. Okay, so the sketch is fully constrained. Change the display back to shaded with edges. Finish. Now the axis of revolution, I'm going to use this Z axis. And then the center point, click on the center point here. Now the angle of revolution is only 30 degrees. So the start angle is 0 degrees and the end angle is 30 degrees. I'll set the boolean to none because you're going to pattern before we unite them. Okay. Now we want to pattern to get 5 extensions in total. So come to pattern feature, select feature, click on this extension. The layout will be circular. Specify vector, you're going to use this Z-axis. And then the specify point, again select any center point of the part. And then you are going to need 5 extensions in total. The spacing should be count and span. The span angle 360 for a full circle. Show results. So this is what we want. Okay. Now we have to unite them. So come to unite. The target body should be this base. The tool body, click on the 5 extensions. Okay. Next, you are going to create the holes. So let's start with these 10 holes. So they're actually countable holes. So come to the hole feature. A general hole. The hole direction normal to face. The form should be a counterbore hole. The counterbore diameter is 15. The counterbore depth is 6. The hole diameter is 10 and the hole depth 20. Now the depth limit, set it to value, and then the depth of 20 millimeters. The depth to the cylinder bottom and the tip angle should be 0 because we don't want any tip angle for the hole. Now come to sketch section. You have to specify the centers of the hole. So click on this face. Okay. Now you can see there is a circle here where all the centers are positioned on, and the radius of the circle is 75. So first create a circle. So the diameter is 75 times 2. So the 75 is the radius, so 150 is the diameter. Now click on the circle and then make it a reference circle. Now place the first point here. Now we want to make sure that the point is horizontally aligned with the center. So right click, select from list, and click on the point, and then click on this center and make them horizontally aligned. You can see sketch is fully constrained, so we can now pattern. So pattern curve, select the curve, click on this point, circular layout, specify points, click on this center here, spacing, count and span, and then we need 10 holes in total, span angle 360. Okay, now finish. Okay, and then we create this hole. So the hole has a diameter of 45 and a depth of 15. So extrude, sketch section, on this face. Okay, then a circle of diameter 45, finish. Now extrude inside, so reverse the direction, and the end limit 15 millimeters. Set the boolean to subtract because we are creating a hole or we are removing material. Okay, next we create this. We can see there is a counterbore hole here. So again, hole feature, sketch section. Now rotate the sketch and click on this face. Okay, and we place the center of the hole on this origin. Finish. Now the form is also a counterbore. The counterbore diameter 130 millimeters. Counterbore depth 15 millimeters. The hole diameter itself is 25, and the hole extends up to the next surface. So the hole diameter 25, and the depth limit, now set it to until next. The boolean subtract. Okay, so this is what we have. We can now add the unspecified fillets of radius 3 and a chamfer of diameter 3, which is a symmetric chamfer. So edge blend for the fillets, radius of 3. We click on these edges. Okay, and then a chamfer, make it a symmetric chamfer of distance 3 millimeters and click on this edge. Okay, then we can hide this sketch, so click on it, hide. You can also hide the datum coordinate system, and then we change the appearance, come to true shading, and then set the global material to glossy plastic wash. So yeah, that's how to model this part with Siemens NX. So now let's model with SolidWorks. So we are inside the SolidWorks window. Create a new part file. And this is our SolidWorks 3D modeling workspace. You're going to start with the base cylinder. Has a diameter of 180 millimeters and a height of 20 millimeters. So features, extruded boss base on the top plane. Draw a circle of diameter 180. Exit sketch. Then the height of 20 millimeters. Okay. And then we make this cone. So we are going to use a revolve boss base. So sketch. I'm going to sketch on the front plane. So we sketch half the profile of the cone and then we dimension. So the diameter of the base of the cone is 120 millimeters. The angle of inclination here is 20 degrees. So from this point to the center line is 120 divided by 2. Since we sketched half, this angle of inclination is 20 degrees. Our distance from the base to the top here is 100. So fully defined sketch. Come to features, revolve boss base. Make sure the angle is 360 degrees and the axis of revolution, just click on this vertical line. Merge results. Okay. Next we add these extensions. So again, sketch on the front plane. Sketch the rectangle which is inclined and then we dimension. So the distance from this point to this line is 19. The angle between this horizontal line and this line is 20 degrees. From this line to this point here, it's 19. This line to this line, the angle is, okay, that's 20 degrees already. So I think that is because of the perpendicular relation here. You can click on it and delete it. Right click. Okay, so right click on it and then delete. Now this angle is 20 degrees. Make sure this line, click on it, hold the shift key, click on this line as well. Make sure they are parallel. You can see there is another perpendicular relation here. Just right click and delete it. Make sure that this line, click on it, hold the shift key and click on this line. Make them also parallel. Now the distance between this line and the line here is 6 and the full length is 48. This is 6. And the full length here is 48. So fully defined sketch. Revolve boss base. So we need an axis of revolution to revolve this sketch. So close. And you're still under the sketch. So we get a vertical line in the center of the part. Click on it and make it a reference line. And again, revolve boss base. And now this line is the axis of revolution. Now the angle of revolution of the extension is 30 degrees. So 30. You have to make it symmetric about where you made the sketch. So we just set the direction to mid-plane. Okay. Now we pattern to get 5. So under linear pattern, you can see the circular pattern. The features to pattern, just click on this feature. The revolve 2. And in the direction, click on any circular face. You want 5. Okay. Next, you create the holes. So again, you create the counterbore holes. So hole wizard, legacy hole, and then the type should be a counterbore hole. Counterbore diameter 15, counterbore depth 6, hole diameter 10, hole depth 20 millimeters. Now the hole depth set it to blind, and the hole depth 20 millimeters. Now come to positions, click on this face. Now let's place the center of the holes on this face. The circle on which the centers are on has a radius of 75. So first sketch a circle, and the diameter should be 75 times 2. Click on it and make it construction geometry, and then place the center with the point tool. Place the center here on this point. And we want to pattern, so come to the circular sketch pattern. Under the entities to pattern, the point has already been selected, and then the point to pattern about has also been selected. We need 10 holes in total. Dimension the radius. Okay. You can see it's underdefined, so just click on this line, make horizontal. Now everything is fully defined. Okay. Then we create the top hole, has a diameter of 45 and a depth of 15. So we're going to use the hole wizard again. A legacy hole, this time a simple hole of diameter 45 and a depth 15. But you make sure that end condition is set to blind before we can put in a value for the depth. Come to positions, click on this face, and then replace the hole in this center here. Okay. Then we add this counterbore hole. So again, hole wizard, legacy hole, a type of counterboard. This time the counterbore diameter is 130, the counterbore depth 15. The hole diameter is 25, and the hole depth should be up to the next surface. Now set the end condition to up to next. Come to positions on this face, and then replace the center of the hole in the origin. Okay. Then we add a fillet of radius 3 and a chamfer of diameter 3 millimeters. So fillet, radius of 3 millimeters, a constant size fillet, and a symmetric one. Click on these 4 edges. Okay. Another fillet, we have the chamfer. We're going to use the distance chamfer, a symmetric one with parameter 3 millimeters. Then click on this edge. Okay. We can finally change the appearance, so come to edit appearance. We use the metallic appearance and the chrome. We give it a chromium plate appearance. The background as well, can change it to this. So yeah, that's how to model this same part also with SolidWorks. I hope this video helped you out. If it did, make sure to hit the subscribe button and leave a like on this video. And also share it to your colleague engineers and students so they can know how to model this part with both CAD softwares. That's the end of the tutorial, and I'll see you in the next one. Peace.